Welcome again. Here we are. Today, I'm going to explore math in nature, and I'm going to share some pictures with you. I won't do a lot of talking. I'm leaving it open-ended, inductive style, so that you can draw some of your own conclusions. So here we go. Math in nature. Where might one find math in nature? Like I said, I'm using the inductive approach, which means I give examples and you draw your own conclusions. A picture is really worth 1,000 words, many more actually. So in these first two pictures, I've got two 5-petaled flowers. There are many, many 5-petaled flowers in nature all around us. And I've defined a geometric shape around the setting of the petals. What shape is that? Your question. This famous building copied the amazing shape and is named after the shape. Do you know the name of this building? Explore and find out. So we have math in nature, but in architecture, some of the shapes are also copied. There will be another session where we show geometric shapes in architecture. Whole other ball game. Let's go on. And this is the zinnia flower, which has, I've defined 3 common geometric shapes. When this pattern is done like this, several shapes combined in one, what is it called? Do you know? Try to find out. The zinnia flower, and there's a little bee in the flower. Do you see it? Attracted to that bright pink. Now these are palm fronds, and I've used white lines to identify a geometric configuration. Have you learned about that yet? There's many more like it. And also in architecture, this geometric configuration is very prevalent. Explore around your home. See if you can find examples of this geometric configuration formed by palm fronds and by many other types of leaves and plants in nature. Now here is a plant with an unusual shape of the leaves. Most leaves are sort of oval. This one has a different shape. And I've put 2 yellow geometric figures hovering over the shapes to draw the parallel. Very fascinating. Now this one is a spiraling plant. It's a kind of cactus. Now, we will notice, maybe, hopefully, that on many math textbook covers, they use the spiral. There's a reason for that. I wonder why. Do you ever wonder about why certain pictures are on your math textbooks? There are many pictures of plants and pictures of buildings. Why? They're telling you something. It's great to go explore and find out. And let's look at this one. This kind of spiral comes out of vines that attach themselves. Have you ever noticed that phenomenon in your garden or among overgrown bushes? Keep an eye out for similar behavior from plants. Look around, you're going to find many, many features like this in nature. Now, some plants look like animals. Is this math or not? It might be, because there are things that come together in the plants that make you think of animals. The color scheming, the way the patterns are drawn or shaped or feathered on their bodies. Take a look. Let's figure that out. And I think I've got 3 more. This is an orchid. It looks like a bird, but take a look at the different shapes that come together to produce this very unique orchid. What shapes are there? Why are they so well defined, brightly colored? Beautiful. Is this seaweed or is it a fish? Again, what shapes do we know in math are combined to create this creature? What shapes? My questions, your answers. And the last one, another question. This one is so full of questions. Monster or plant? Again, examine what looks like a mouth with teeth and eyes and scales. Can you find one like this somewhere? It's actually an aquatic creature, animal, vegetable, plant, whatever. You find out. This will be fascinating for you to find out and determine what these are and where they came from. Have fun with it, and thank you.